In this video, we're going to take a look at descriptive statistics. But first, I want to talk a little bit about the populations and samples, which is a review from the first module. So the idea behind statistical measurement is that we have a population of interest. And so this population could be anything like all females, or it could be Virginians, or it could be students at Radford University. But there's this idea that there's a population that we're interested in drawing conclusions about. And it is not convenient or cost efficient to gather information about every member of the population. So what we have to do is draw a smaller sample and hope that it is representative. We got a sample here. And so we're going to use facts about the sample to draw conclusions about the population. Now, just a little bit of terminology and symbolism here. So the population is going to have characteristics that are called parameters. And these are the things that we're interested in drawing inferences about. So, for example, we might be interested in the mean. That is the average. And so that the population mean is going to be denoted with the Greek letter mu. Okay? So another population parameter that might be of interest is the variance. That is, how much variability is there in some measurement of interest. So for example, we're going to take a look at IQ test scores. And we might want to know the mean for the population, or we might want to know how spread out those IQ measurements are. So we also want to talk about the variance, which so that is symbolized as the Greek letter sigma with a square. So sigma squared is variance. And in addition to that, another measurement of dispersion is the standard deviation. So the standard deviation has a very simple relationship with the variance. It is simply the square root of the variance, so it is denoted as sigma just by itself. Okay, so these are the core population parameters. Now, since we can't really observe those directly because we're not likely to measure the entire population, instead we look at the characteristics of our sample. And so these are called the statistics. And the statistics of our sample are going to be estimates of the parameters of the population. So we're going to have a sample mean as well as the population mean. And instead of denoting it with the Greek letter mu, to keep it distinct from the population parameter, we're going to denote it as x bar. So x with a line over it. So this is our sample mean. Okay, and so we can also have a variance in our sample. And instead of using the Greek letter sigma, we're going to just use s, and it's going to be s squared. And so similarly, we're going to have a standard deviation, which is just going to be s. Okay, so the key idea is that we have these population parameters that are going to be approximated by these sample statistics that we have. Okay, so let's take a look at computing some statistics. So we've got here in this Excel worksheet a set of observations about IQ. So we've taken a sample of 6 people, and we've got IQ measurements for each of them. So we're interested in knowing some things about the population. Now, with a sample this small, we're probably not going to get a good approximation, but this sample is just meant to demonstrate how to take some of these calculations. Okay, so the first thing, the simplest way to understand this data is to just take a look at the mean. Okay, so we'll do this in Excel. let's go ahead and take a look at some notation. So okay, so calculating a mean is, that's not difficult. We already know how to do that. So let's just review. So if we are going to take our x bar, so all we need to do is add up each of the individual values. So we'll do I for I equals 1 up to n. So we take each observation, add them up, and then we divide this complete sum by n. Okay, so don't let this symbolism throw you here. This conventional notation is fairly easy to read if you just step back and remember that what we're doing here is these i's represent each observation. So I is going to go from 1 up to n, which in our case over here is 6. So for each of those 6 rows, we add up the observed value, and then we divide by the 6, the number of values here. Okay, so let's go ahead and do that manually. So that's just going to be, okay, in Excel, it gives us a function sum. So add up all these numbers and then divide by 6. Okay, now we could also just use the, use the Excel function, which is average. Take the average of these. Okay, all right, so that's pretty straightforward. Okay, so there's what we do with the mean. So we're also interested, instead of just, we have an idea of a central tendency or the typical value. We got an IQ score here about 110. That's representative of the population average to some extent. So we also might want to know, well, how spread out are these? We can do that with a number of different measures of dispersion. Your book mentioned range as one. So we can observe here that we have a 90. It goes all the way from 90 up to 130. So that's a difference of 40 points. So that gives us some idea of how spread out the data are. But a more precise measurement, a more informative measurement is going to be the variance. And so rather than just get into the notation for the variance, let's go ahead and construct it piece by piece. I'm going to start off by adding a column here where I take the difference between the observation, that is what's here, and the average. Okay, so we kind of want to know, well, how far are these values from the average for the whole sample? So we can just set this equal to, whatever is in here minus the average down here. Okay, all right, so we see that that's a 0 because this thing doesn't deviate from the average at all. In fact, we can call this column here the deviation. Okay, so we want to know how far do these values deviate from the average. Okay, and I'm going to go ahead and make this an absolute cell reference so that when I copy it, so I can paste this down and it'll give me how far each x, that is x sub 1, x sub 2, x sub 3, how far each one is from the average. Okay, so now we have all of the different deviations. Well, why don't we just add these up? Well, the obvious problem is that if we add them all up, they are going to be equal to 0. Okay, and that's always the case because of how the mean is calculated. So instead of just taking, instead of adding these up, maybe what we could do is first square them. Okay, so let's take the squared deviations. So we'll call this column squared deviations. And we're just going to take that and set it equal to this, well, times itself, because that's the same as squaring. Okay, so 0 times 0 is 0. Okay, all right, so now we see that something that is 10 points above the mean and 10 points below the mean have the same squared deviation. Okay, so that helps us. Okay, so now that we've got the square deviations, now in order to get our our variance, what we have to do is add these up. So let's call this cell down here the sum of the squared deviations. Okay, so I'm just gonna take this and do sum of all of these. Okay, all right, so we have sum of squared deviations of 1,000. Okay, all right, so now instead of just recording that, because that's going to be that's a fairly large and uninformative number, because we're kind of dealing with sort of an average, we want to know on average how far are these values from the mean. We will go ahead and divide that by n. Now, there's a little trick in here where variance for the sample is calculated as dividing that sum of the squared deviations by n minus 1. I'll talk more about why that is in just a minute. But for now, let's just go ahead and say, okay, well, this is going to be equal to, so this sum of squared deviations divided by 6 minus 1. Okay, so a variance of 200. All right, so let's just say, okay, so we've got mean here, and now we've got variance. So we did it piece by piece here. So we took each IQ, found its deviation from the mean, and then we squared that deviation, and then we add them all up, and then we divided by n minus 1 and got 200. Okay, so this is doing it manually. And now we'll see that when we use the Excel function var_s, so give me the variance for this sample of this range of numbers here, we see that it gives 200. Okay, so this is just intending to show you what a variance is. Okay, now we can take this. The problem with the variance, of course, is that its units don't seem to make any sense. We have an IQ, set of IQ scores that only go up to 130, but this variance is 200. So the magnitude doesn't really make a whole lot of sense. And the reason is because we've squared these deviations. So this thing was 10 points off, but its effect on the variance was actually 100. So one way to make more sense of this is to go ahead and take the square root of that variance, and the square root of the variance is called the standard deviation. So we can use the Excel function sqrt to take the square root. So the square root of that is going to be 14.14, or we can use the Excel shortcut and just use stdev.s because it's a sample. So now give me the standard deviation for this sample, and we'll see that it's exactly the same number. Okay, so I've shown you a couple of different ways of going about getting these numbers. So this is using the Excel functions. This column here just uses the Excel functions directly. Here we're doing all the calculations manually. Okay, so let me just very quickly go over the notation then. I think that the notation in your slides will make a little more sense now that you've seen it worked out. Okay, so this is how we found x bar. So now let's take a look at the variance, which I said for the sample is denoted as s squared. Okay, so remember we started off with finding the deviation of each x from the mean. So x minus x bar. Okay, then we took the square of those deviations. Okay, then we added them all up. Now we could put this I equals 1 and n here, but we don't really need that because we know what this means. So then we added all of these up, and then we divided by n minus 1. Now, if what we're trying to do is get at the average distance from the mean, why is it that we're dividing by n minus 1 instead of n? Well, there are theoretical reasons for this, and it has to do with the fact that what happens is remember that these statistics over here are intending to estimate the population parameters. And it turns out that the sample mean does a very nice job of approximating the population mean. But the sample variance, if you were to just divide it by n, that actually does not completely represent the variance of the population. What happens is if you divide by n, it tends to give you too small of a value. So the population variance tends to be a little bit more than what would be represented by that sample variance with just n. So by subtracting 1, we make this denominator smaller, which makes the whole thing larger. So we have to kind of do this thing to bump that up a little bit to represent the true variance of the population. Okay, and so now that we have we've got the formula here for the variance, all we have to do to get the standard deviation, that's just going to be the square root of that. So rather than writing that whole thing out again, I'm just going to do that. Okay, so the slides in your book just give you this, but hopefully seeing it this way makes it a little bit more clear what's going on here.